Hi guys, welcome back to AP Calculus. Mr. Robeson here. We're starting Unit 6 today. Unit 6 is going to be fairly short and it's going to be combined with Unit 7 and Unit 8. So it's just 6.1 and 6.2. Today we are looking at differential equations, general solutions versus particular solutions. And we'll look at how to find these solutions of differential equations. Too far. There we go. So a differential equation is an equation that involves the derivative or derivatives of a function. For instance, all right, y prime plus y double prime minus y equals 7. That's a differential equation because it involves derivatives. We could also say dy dx equals 2x. Also a differential equation because it involves derivatives. All right, solutions to differential equations come in two different forms. We have our general solution, which in other words still has this plus c. That's why it's general, because it's a family of functions that have all these different c values. Particular solutions means that we have solved for the c value. So we know what c is, we plug in the number, so we'll have just numbers and variables. With this one, we'll still have a c that could be any number we want. All right, so let's get rid of that. Check to see if each is a solution to this differential equation over here, the second derivative, y double prime minus y equals 0. So if we need to know what the second derivative is to check that, so we just take derivatives here. So y prime, derivative sign is cosine. Second derivative cosine is negative sine. So now if we plug this in, if we do y double prime minus y, that would be equal to negative sine of x minus y, which is just sine of x. All right, so these aren't going to cancel out. This is actually going to be negative 2 sine of x. So that does not equal 0. So nope, this guy is he's a no. All right, let's try the next one here. Switch colors. So again, we need to get the second derivative. So we just start taking derivatives. When we take derivatives of this guy, we end up with rewriting it times derivative of the exponent, which is negative 1. So we're going to get negative 4 e to the negative x. And if we take another derivative, we're going to get another negative 1 down here. Oops, y prime. So our second derivative will be positive 4e to the negative x. So now if we try that, the second derivative is this guy. Y double prime minus y is 4e to the negative x minus our original 4e to the negative x, which does equal 0. So yeah, this guy is a solution. He works. Let's try one more. All right, so this one, again, we need to know two derivatives. So derivative of e to the x is just e to the x. The constant out front just stays constant. So there's our first derivative. Our second derivative is c e to the x again. So if we do y double prime minus y, we'll get, here's y double prime down here, c e to the x minus our original function c e to the x, which does equal 0. So yep, that guy works too. All right, so this one was not a solution. The other two were solutions. Is each solution a general solution or a particular solution? Well, this guy is a solution. We don't have any plus c here anywhere that's unknown. Like we know this is 4, we know that's negative x. So this is a particular solution. All right, and then this one is what we call a general solution, since it has a plus c, which means any number we plug in here for c is still going to work. So we could plug in 1, we could plug in 2, we could plug in negative 100, we can plug in 1,000, we could plug in pi. Any number we plugged in here, it would still work. That's why it's a general solution, because everything of this form would still be a solution. All right, let's look at finding particular solutions. So first one, just some examples here. For the differential equation, x times y prime minus 3y equals 0. So it's a differential equation because this guy right there, the y prime. Verify that y equals c times x to the third is a general solution. All right, well, we need the first derivative. So y prime is, bring down the 3cx squared is what we get for the derivative. And now we're plugging in here. So we get x times 3cx squared minus 3y, and y is this guy, cx cubed. So 3 times this x gives this x cubed. And we still have a 3c out front as a coefficient. This one we still have 3cx cubed. And they're exactly the same. So they do equal 0. It does equal 0. That checks out. So this is a general solution. It's got that C though. So now we go down here, find the particular solution with the initial conditions y equals 2 when x equals -3. I don't know if we really need the word initial, but with the conditions y equals 2 when x equals -3. So that means that point will work in this equation. So that means 2 will equal c times -3 cubed. I'm just plug it in for 3, or -3 and 2 there. So this is what, -27? So we divide, we get -2 over 27 is c. So that means the particular solution, which they asked us to find, will be plugging in that up here. So we get y equals -2 over 27 times x to the third. And we know that this will still work here because it works with any c value here. So it will specifically work with c as -2 over 27. Let's go to purple. All right, now we're told that the derivative of some function is e to the negative x. Find the particular solution if f of 2 is 3 minus 1 over e squared. Well, if the derivative is e to the negative x, that means the original function must be the integral of e to the negative x with respect to x. All right, we're just going up a function. All right, so if we integrate this, technically we would do substitution. So this section does involve, it does involve integrals and derivatives at the same time. So we put a negative in here for the dx. We put a negative outside to cancel it out. So we get negative integral of e to the u, which gives us negative e to the u plus c, which gives us negative e to the negative x plus c. So we get y equals negative e to the negative x plus c. All right, so this is the general solution. Now we're given this bit of information here. All right, so I said y. We could have also just as easily said f of x. So now if we plug in 2 for x, we get this. So we should get f of 2 equals 3 minus 1 over e squared, which is negative e to the negative 2 plus c. All right, so just switching the order of the terms and bringing this down, this would be c minus 1 over e squared. So we've got this equals this. So we can cancel out the 1 over e squared from both of them. And we get that. Looks like c equals 3. So that means our particular solution would be y equals, or f of x equals, negative e to the negative x plus 3, or 3 minus e to the negative x, like that. So this is the particular solution, because we have now solved for the c. All right, so that's how we solve some basic differential equations, and that's the difference between a general solution and a particular solution.